Today we're going to learn about atom economy. When a chemical reaction takes place, atoms are neither gained nor lost when you move from the reactants to the products. In industry, we tend to only want one of the products from the chemical reaction. That means anything else produced is waste. If we look at this chemical reaction, we have reactant A reacting with reactant B to form a desired product and potentially one or more waste products. The atom economy tells us how much of the starting materials end up as our desired product. We can calculate this by computing the molecular mass of the desired product divided by the total molecular mass of all the reactants multiplied by 100. The reason we multiply by 100 is because we want to have this ratio as a percentage, so we know what percent of the total mass of the reactant ends up as our desired product. Let's work through an example together. Chloroethane can be produced from ethene and hydrogen chloride in an addition reaction. What is the atom economy? Can you tell me what you think the desired products and reactants are for this reaction? Chloroethane is the desired product, and ethene and hydrogen chloride are the reactants. So if we wanted to write this as a word equation, this would be ethene plus hydrogen chloride forms chloroethane. If we wanted to write this as a balanced chemical equation, we then have to write C2H4 for the ethene reacting with HCl for the hydrogen chloride, forming C2H5Cl. Is this equation balanced already? Yes it is. So we have 2 carbons on the left hand side and 2 on the right. 1, 2, 3, 4, 5 hydrogens on the left hand side and 5 on the right. And then 1 chlorine on the left hand side and 1 on the right. So we now know that our equation is balanced. Before we even plug in the numbers, can you think as to what the atom economy is going to be, considering we only have one product? Now, since we only have one product, that means there's no waste. And if there's no waste, then that means all the product that is formed is the desired product. Let's work through the numbers. So here I have the atomic masses of all the elements involved in this reaction. So to work out the molecular mass of a molecule, you add up the atomic masses for each of the atoms in that molecule times by the number of atoms that there are. So for C2H4, you would have 2 times 12, add 4 times 1, which would give you 28. For HCl, you would have 1 for the hydrogen, add 35.5 for the chlorine, which will give you 36.5. Now, if we go back to how we would work out atom economy, we know we want the molecular mass of the desired product divided by the molecular mass of all the reactants. When you work out molecular mass, the molecular mass of the product has to always equal the molecular mass of the total reactants. And therefore, since there's only one product, we know that the molecular mass of this one singular product has to equal the combined molecular mass of both of these reactants. That would give us 28 plus 36.5, which is 64.5. Another way to calculate this would to do 12 times 2, add 5 times 1, add 35.5 times 1. And this would again give us 64.5. So if we were to then plug this into our equation, we would have 64.5 for the desired products. Let me draw an arrow to that. So we have 64.5 going on the top of our equation here, and we have 28 plus 36.5 going on the bottom of our equation, which we already know is equal to 64.5 times 100. So essentially, our atom economy is equal to 64.5 divided by 64.5, all multiplied by 100. This is the same as 1 times 100. And so we can see from this equation that our atom economy for this reaction is 100%. The reason that this is because there are no waste products formed, and so you could probably work this out without even having to do the calculations. But here the calculations does show that the atom economy of this reaction is 100%. Let's look at these reactions. Glucose goes to ethanol plus carbon dioxide, and it has an atom economy of 51%. Carbon monoxide plus water goes to hydrogen plus carbon dioxide. Glucose plus oxygen goes to water plus carbon dioxide. 3 separate reactions. If we assume that carbon dioxide is the waste product in each reaction here, the first reaction has an atom economy of 51% for ethanol. The second reaction has an atom economy of 7% where hydrogen is the desired product, and the last reaction has an atom economy of 29% where water is the desired product. Which of these do you think is the most efficient reaction? So the most efficient reaction is this one. The reason that is because the higher the atom economy, the less waste you have. And so if you're getting more of your desired products from your reactants, then the reaction is more efficient. This is very important in industry because we want to have the most efficient processes so we can save on energy and save on the raw materials that we're using to form different products. That's why we want to make sure that we can maximize atom economy wherever possible. Let's work through a practice question together. An equation for the reaction is nickel oxide plus carbon goes to nickel plus carbon dioxide. Calculate the percentage atom economy for the reaction to produce nickel. It gives you the relative atomic masses of the elements and the relative formula mass of the only molecule needed. So we know that the atom economy is the mass of the desired product, which is nickel, here, divided by the mass of all the reactants added together. So that would be atom economy equals the mass of the desired product, which is nickel, so that would be 59, divided by the mass of the reactants added together, which would be 75 for nickel oxide and 12 for carbon, all multiplied by 100. This is equal to roughly 68%. So that's how you'd write for that question. You have a mark for identifying what the equation for atom economy is. You have a mark for being able to do the calculation by plugging in the numbers. And you have a mark for getting the right figure for the atom economy.